Hi, I'm Dave Wilson, and I'm presenting today to you the North Okanagan Wastewater Recovery Project. And more specifically, I'm going to focus on the processes that we use to define an affordable wastewater solution. First, a little bit about myself. I'm a professional engineer, been in value engineering for over 25 years, done lots of value studies. I've been heavily involved in the value industry uh, as as a 4-year term as president of SAVE International. I'm a member of the College of Fellows, certified value specialist for life, certified professional facilitator, and actually right now I'm actually serving as the new education director for SAVE as well. So today I'd like to focus on 5 things. First, the project concept and challenges, the value strategy that we used on this particular assignment, some of the key value opportunities that emerged from the workshop, and then finally get into defining how we use some tools and tricks to get to a point where we could define affordable solutions. And as an added bonus today, I'm going to share with you what the design team has just told me within the last few days about what they're proposing to do. And this is sort of a follow-on from our value study. So the key project goals for this particular project were to support growth in a fairly rural area in Western Canada, and more specifically in the province of British Columbia. It's a very small rural area, lots of agriculture, and relatively small population base. The idea behind the project was to support growth, and they wanted to entice it as they uh, as they sort of move forward, and to sort of deal with other specific issues in terms of water quality. They have septic systems everywhere, and they have problems with water quality, and also too to create a more sustainable irrigation supply for the area agricultural base. Most importantly, the idea behind this project was to actually create a regional solution combining a number of municipalities together in here. And so the municipalities that we were dealing with were the regional district of North Okanagan, Spalmachine Township, which was there, and to some extent we were also dealing with the town of Armstrong as well. Project concept is fairly straightforward. It involves introducing gravity and force main sewers. Uh, because of the topography and the location of where the lift station was supposed to, or where the treatment plant was supposed to be, they introduced lift stations. It's a small plant. It's a SBR plant, but it's only a 1.7 megaliters per day. And that's very, very small. But the idea was to collect the wastewater, treat it, store it, store the reclaimed water in a pond, and then ultimately distribute it back for agricultural irrigation use. The project budget was set in 2018 at $36.9 million. It's a fairly modest project. Uh, a significant amount of that money is actually coming from funding of the provincial and Canadian federal governments. But that isn't the problem. The problem comes a little bit later when we talk about where the budget is. The project concept was actually developed after they'd already bought a site for the treatment plant. Now, normally that's not really what would happen, but a piece of land became available. They pre-purchased it to meet the schedule, but unfortunately, the size and location of this piece of land really limits the potential alternatives that they could have been able to consider. So this is the site for the treatment plant specifically, and you can see it's very congested with a number of different processes. The different colors represent sort of phasing activities as to how they would expand the plant from 1.7 to 7.5 megaliters per day. And But you can see that they've used all the land available. It's a very, very tight site to work in for construction, but also a very tight site, which requires, unfortunately, a really process-intensive solution and not necessarily the challenge here. So we get to the cost estimate. The cost estimate in 2021 was $48.8 million. So there's about $12 million that they're over budget for this particular project. And the most important thing is that there's no additional grant funding coming from the federal or provincial governments. Their share is locked. So anything that comes out of this in terms of extra dollars or required for this for extra dollars, that's got to come from the municipal partners. And the municipal partners had a very, very small stake in the actual capital construction of this particular project. So this is a major problem. And we have to ask the question, why? What happened to this? So when we think about major cost increases in this project, we have to sort of step back and say, why? Why does this happen? And probably the bigger question is, can a sustainable regional system actually be created at this location given the economics and some of the constraints? And just to give you a sense, this chart here really, this cause and effect diagram really illustrates sort of the 4 key areas where there are substantial challenges associated with the project. And it really boils down to real challenges related to regulations and policies, operations, funding sources, and ultimately the governance. And in fact, actually, they're designing or conceptualizing this project right now and have not actually decided how they're going to operate this system. And that's a real challenge. So let's talk a little bit about the process used before we get into the value opportunities. And the thing that I want to sort of confirm with you right now, so you understand, part of the hardship, this was done during the pandemic, and so it was a virtual event. And if you've been involved in any of the workshops or any other meetings, you know that you really have to sort of take people's well-being and wellness into account as you're scheduling these events. There's a couple things that I wanted to sort of highlight for you. So in a virtual event, there are lots of considerations, but the number one is the duration of the different stages or sections of the workshop and how many breaks you're going to be able to fit in. People can't sit at a screen, they just burn out. So you just have to really think about that. So we're always looking at sort of short duration type workshops, but we're also looking at short day workshops as well. So in this particular case, we used 4 6-hour days with quite a few breaks in there to help people be able to operate through here. The scheduling that we wanted to do in terms of our objective for scheduling, was to maximize the amount of development time. And the first question says, why? Well, because it enhances the value opportunities and the quality of the value opportunities that you're going to get out of the workshop. And when you think about an investment of time, you're really worried about trying to get everything into the workshop and get the outputs out as quickly as you can. So I'm going to discuss a couple of ways that we did this. Some of the modifications to a standard value engineering study that were incorporated here was actually what called a pre-workshop meeting, and it's shown in the first green box. It was done so we did a project overview presentation, and then partway through the VE team's review of the documentation, so we actually had a meeting which allowed them to talk amongst themselves, really focused them, assured that they were going to be ready, and we actually produced some slides that would be shared during the workshop. And then later on, after the workshop, is when we included sort of an evaluation meeting where we took a lot of the input information and had a chance to sort of uh, reflect on some of the inputs, modify and sort of get some better up-to-date info. But it turned out that that was just the thing to do here, because we were able to collect a lot of additional information from the design team that really didn't have access to during the workshop, and we're able to proceed with making some of these affordable solution choices that we're going to talk about. A couple of things in terms of ways to reduce the amount of or make the time available for creativity and development is to actually reduce some of the other activities. And one of the areas typically that it's got to be the number one complaint is that doing function analysis takes way too long. It's just a speed bump before you get into ideas. And if you can get away with that, that's great. But in most cases, I've found that the teams are just ready to move and they need to move. And a lot of the time, what I do is I use a sort of a rapid fast system, a fast standing for function analysis system technique diagram. And how I do that is I partially pre-build or even co-opt fast diagrams from other similar projects. So for instance, a wastewater treatment plant is a wastewater treatment plant is a wastewater treatment plant. They do similar things, and then you use the opportunity to modify those to gain the consensus. Forget about what you've been taught about function analysis is all about team building. All it is it frustrates about 3/4 of the people. They're all specialists. You're a specialist if you're a team leader that should be able to put this together and then get them to work it. I tend to use mind maps. This is an example of one. And I find that it's really intuitive. People understand it. They like to see the colored boxes move around. And I use colors. The colors here, you can see your reds are value targets. Those are the things we're going to brainstorm on. The green one in this particular case was the basic function. I don't worry about some of the other dimensioning things that you've probably been taught, because we're trying to get this job done and move forward. So some of the key value opportunities that we identified, and I'm just really going to click through these fairly quickly just so you get a sense of them. We looked at phasing the collection system. The gravity sewers would only be in the areas where you're going to produce wastewater. There are some areas that are not going to be developed for a considerable amount of time. So why would we do that? We'll look at ways to simplify the connections to the households as we go along. Another idea was to actually, instead of having huge lift stations, use low pressure grinders on these very, very dispersed rural properties, and have them pump in a low pressure system to major trunk sewers and then lift every once in a while. Another idea was to sort of combine those sort of thoughts and simplify some of the connections, but eliminate major portions of the gravity sewer and the lift station. And if you remember from the cost estimate, the gravity sewer, or the collection system, was a substantial amount of the overall project. Another one was pumping, and so these are all examples for the collection system. We also talked about integrating with another community that they hadn't really sort of dealt with. It was the next community over, but they had very similar needs, and they had a system that was really close to to where we were going to be building. So those could be combined, and you then get a larger base to be able to produce this reclaimed water. Some examples that we looked at for the treatment options were to put an aerated lagoon in. So it obviously wouldn't fit on the land that they've already purchased, but it would go somewhere else up near the reclaimed water storage area. and it's really sort of right-sized for the volume that they're dealing with. One was to modify how they were going to build the SBR treatment plant. And this little diagram probably doesn't mean much to you, but really what they were originally going to do was sort of hopscotch the construction of these SBR cells. Instead of using chemicals for disinfecting, use UV. And for dewatering, one of the issues with dewatering was trying to deal with the sludge. And in this particular case, we were looking at using geotubes, which are basically just large sacks, filling them up, letting them dewater naturally, and then dispose of the bags with the sludge in it. And that actually takes out a lot of equipment in the plant, and so that reduces the footprint and everything else. And finally, we looked at providing packaged plants. These are plants that are actually used for industrial sites to treat wastewater, and the size of this particular project really fits well within the parameters of a prepackaged solution. There's another example. So when we get into defining affordable solutions, we start to think about the need to choose ideas, and you got to make those decisions fairly quick. But you have to be decisive. You have to rely on the expertise. You know, you've probably seen examples, or maybe you've done it yourself, where you've got these huge or elaborate numerical calculations trying to figure out an evaluation and which alternative or which ideas are better or worse or so on, considering a whole bunch of things. I'm just going to tell you right now, forget about it unless you absolutely have the time to do it. Most times in workshops we don't, but you've got a bunch of technical specialists in there that have the experience to look at an idea and be able to conclusively say, yes, I think this is a good idea for us to look at, and then you let the sort of the development of that idea sort of gauge whether that thing's going to move forward or not. So rely on the experts. Just don't wind up with sort of that ignoring their input for the sake of looking at some numbers. So how do you meet the budget? Well, in this particular case, we were able to consider combining value opportunities. You got to make sure that they're compatible. They have to have some kind of a measurable cost impact, or why would you bother? And you have to have a limited schedule impact. So those are sort of three starting points that you want to have. This diagram here shows a sort of an alternative cost profile. It's just an example to illustrate. But the question is, if you have a target cost, in this case are $36.9 million, and the baseline is quite a bit higher than that, can we combine alternatives to get down or in around that target cost? So one way to sort of confirm whether, once you've got sort of the ideas figured out as to which ones you can glue together, is whether or not you actually get value out of those choices. And in this particular case, we use the weighted additive method, which identifies a number of performance attributes. You assign weights to them, you score those options, and you're always comparing back to the baseline. And then ultimately, you look at the cost profiles and you do a best value score, which is sort of based on performance, the relationship between performance and cost. So here's just a quick example. The upper left is the functional performance attributes and the weighting process. Then we check the scores for performance. Then we check the cost components. We come up with an alternative. We come up with the evaluation summaries. And so here's just a quick example of this, and I can appreciate that these numbers are small, but these are some of the math, but it's all automatic once you get going. And so we did it for both treatment and for the collection system. And we never really considered combining it because the design team had to go off. Well, about 2 weeks ago, the design team came back and said, hey, this is what we're going to do. They're going to look at two different options. So they're going to look at option A, which is the aerated lagoon, and that was something that we had really promoted. And they're going to combine it with a low pressure collection system. They've changed some of the numbers for contingency and engineering costs, and they've made some adjustments on how they're going to store and distribute the water. And their numbers are a little bit different because they've done more work on it and they've got it more definitive, but they were in around 39 million as opposed to $49 million. So they've dropped about $10 million at that point. Alternative B was to look at the mechanical batch plant, the one that they use for industrial uses, and could they make that work? And they've done a number of combinations. It's a little bit higher, but they're going to carry those two through as alternatives. And they've also taken another idea, which I didn't highlight before, which is the integrated project delivery model. And in this particular case, they're going to hire the IPD proponent, and then they're going to carry this two-stage or two assessment options through in sort of a refinement phase. So we're at the end of our presentation right now. I realize that went fairly quickly, but just to sort of cover off, we talked a little bit about the project concept and challenges, some of the strategy moves that we made for this particular project in terms of the assessment, highlighted some key value opportunities, and defined how we got to some affordable solutions, and actually demonstrated that the project team has actually taken up a couple of those affordable options, and they're going to go forward with a further assessment. So at this point, I'd like to thank you very much for your attention and wish you success with the rest of the conference. Thank you.